Hello everyone, welcome back to our second session of previous year board question paper. This time I have chosen a topic named real number, and this topic I have segregated in two parts. One is proof of irrationality and another is on the word problem. But before directly jumping into the question part, first we should know that what we are going to do. On the basis of that, what all topics I need to solve first and which keyword I should remember. Now let's see the second slide of this. Second slide deals with the fundamental theorem of arithmetic and HCF LCM product, their relationship, and some knowledge booster. So first of all, everybody should know about the fundamental theorem of arithmetic before approaching towards any questions of real numbers. This fundamental theorem of arithmetic states that any composite number can be written as a product of prime, or the power of product of prime. Second, the difference they have given that HCF and LCM, two things are there. When to apply HCF, when to apply LCM, it all depends on your thinking and logic when you are reading that question. And what is the relationship between HCF and LCM of two numbers? They have taken two numbers as A and B, and they have shown that HCF between two number into LCM between two number is nothing but a product of that two number. What is the knowledge booster they have written? What is a composite number? What is a prime number? Smallest composite, smallest prime, everything is there. Pause the video for a minute and just go through once, write somewhere or take a screenshot. That will help you to solve the further question, upcoming question. Let's go to the next slide. So we are coming to the question number 1, where we have to prove that root 3 is irrational. This we are going to use the method of contradiction. How to start this question? Let's look into that. Now, to start the method of contradiction, so first write this is the method of contradiction. Contradiction means something which is true, first I will take it false. Then I will prove that whatever I have assumed, that part is only wrong. It means the reverse of that will be true. So let's see. So I am assume given root 3 is rational. They have given us irrational, I am assuming it as a rational. And if something is a rational, I can write in the form of P by Q, where P, Q are co-prime and Q should not be equals to 0. Now, the next step is square both sides. Square both sides. When I am squaring both sides, root 3 will result it into root 3 square and P by Q will result it into square. So P square by Q square is equals to root 3. Root 3 into root 3. So root 3 into root 3 will result in 3 equals to P square by Q square. This is the first, make it as equation 1. The second part of this. From the first part what we have got? We can see from the first part we can easily write this part as this. I am continuing with this part. 3 equals to P square by Q square. I can write Q square is equals to P square by 3. Here I am going to use a theorem. What kind of theorem? Since P and Q were the co-prime number, they are prime also at the same time. So if I am dividing 3 divides P square, if a prime divides P square, then that prime will definitely divide P also with power 1. And if a number is getting divided by something, so we can write that number is equals to 3 times K1. This I am going to substitute in our own equation 1. How to substitute? Let's see. Since we know 3 equals to P square by Q square, and we know the value of P we got as 3 times K1. Now this value I am going to substitute in place of P. So 3 times 3K1 whole square by Q square. Q square I am shifting this side as a cross multiplication. So I got 3K1 into 3k1 divided by 3. Now, can you see that 3 and 3 will get cancelled and we got q square is equals to 3k1. I can write this as k1 equals to q square by 3. Do we got any pattern? We can see here I got that q square is equals to p square by 3. This time I got k1 equals to k1 square is equals to q square by 3. It means again I can apply the same theorem that 3 divides q square, which implies 3 will divide our q. Hence we can write q is equals to some 3 times k2. These two boxes where p equals to 3k1 and q equals to 3k2, now combine both of them. What we got? Since p equals to 3k1, q is equals to 3k2, we got. What is the common factor between p and q? We can see easily that common factor between p and q is nothing but a 3. So it means we are getting the HCF of p comma q equals to 3. And what we have assumed? We have assumed that p and q should be a co-prime. Co-prime means HCF is equals to 1, but we are getting HCF is equals to 3. It means whatever we have assumed, that is wrong. Therefore, assumption was wrong. Assumption was wrong. What does that mean? It means root 3 is irrational only, not a rational number. We have assumed it as a rational number. Now the same logic you have to work it on root 2 also. So root 2 is for you, root 3 I have done, root 2 you will solve on the basis of same logic whatever I have taught you here. Just take your time, take 2-3 minutes, revise this how I started. First I have assumed the contradiction part, root 3 as rational. Then what is the condition on p and q, which is very important, that p and q should be co-prime and q should not be equals to 0. This part is very much important for you. Then we did the square and 2 times we did the same thing. After squaring, first what I did, first I have written in the form of q square, then I have written in the form of k1 square. In both the part, if you will see, one time I got p square by 3, one time I got q square by 3. It means 3 divides p square, 3 divides q square. So I can write p as a form of 3 times k1 and q in the form of 3 times k2. And both have the factor of 3 instead of 1. It means that the given question, whatever I have assumed that it is a rational, that was wrong assumption. So what will the contradiction? It means the given root 3 is an irrational number only, guys. Second one, you try at home. We are moving towards our question number 2. Okay, now question number 2. What we can see in a question number 2, a very important part in a question number 2 is that, tell me one thing guys, are we going to solve this question again like the previous question? Prove root 5 is irrational number, check whether root 5 plus 2 is an irrational number. So this question they have given that prove that root 5 is irrational. So again we are going to prove root 5 as irrational like the previous step. So suppose I have proved, suppose same thing I did what I did in the previous method, and I have proved root 5 is irrational number. This we have already proved. I am not going to prove it again because you know the method now how to prove. So with the help of already that I know that root 5 is irrational, can we prove that this part is also irrational? Means irrational plus addition of some rational number is fetching you to an irrational number. Let's see how we are going to do this. This is known as the method of comparison. Method of comparison. What does that mean, the method of comparison? We'll start with, as we started the previous one, let root 5 plus 2 is rational. Now we know if something is rational, it means I can write that number in the form of p by q, where p comma q HCF should be 1 and q should not be equals to 0. But in the previous question, after this second step, what we were doing? We were doing the square both side. So here instead of doing the squaring both side, what I have to do? This root 5 condition we already know. So I will separate root 5 and other terms from each other. How to separate that term? Look here. Root 5 plus 2 I am writing. Now, so root 5 I am keeping here. This 2 I am shifting on the right hand side. It will become p by q minus 2. Correct? Now, take LCM. You will get p minus 2q by q. And here only we have completed this part. How is it done? Now so many things are remaining. Can we say that root 5 and p minus 2q? Since p and q are already a rational number which we have assumed in the second line. So the addition of rational result in rational. Subtraction of rational will result in rational. Division of rational will result in rationals only. So what we got? Since our LHS is equals to root 5, which is irrational number, but RHS is equals to p minus 2q by q, which is not irrational, it is a rational. So since LHS is not equals to RHS, which implied LHS is not equals to RHS, hence our assumption was totally wrong. Assumption was wrong. And assumption was wrong. What does that mean? It means that root 5 plus 2 is irrational. So there are two methods in this real number system to prove the irrationality. One which we did before, when a single number is given to you in terms of irrational you have to prove, you have to do the squaring. Second, when the combination of terms is given to you, in this case what you have to do? You have to do the comparison methods. So two methods, one the squaring, second is comparison. And I am pretty sure that this time also they are going to give definitely this question in the board also, because last 5 years if you will check, every time in 3 marker or 5 marker, in standard paper or basic paper, definitely this question is coming. So students, be ready with this, such kind of question and prepare as well as much, so that you can go and solve all the question either with the squaring method or with the comparing method. Let's go to the question number 3 of today's session. Now, question number 3. Now, question number 3, again, given root 3 is irrational, prove that 5 plus 2 root 3 is irrational. Similar kind of question, this was in the CBSE sample question paper of 2022 and 2023. Means this part is already given to you, only you have to prove that part. But 5 plus 2 root 3, so again we will do the same. Assume 5 plus 2 root 3 is rational. See, first of all you also know that QC means irrational and Q means rational. This is the symbol, standard symbol for rational and irrational numbers. So we are assuming at a rational, it means I can write 5 plus 2 root 3 is again in the form of P by Q. Now, since one part is given to us, given is root 3 is QC. QC means irrational number. So I am keeping 2 root 3 this side first. I am shifting an rational number towards the rational side. Now what I will get? After simplification I am getting P minus 5Q by Q. But one problem I have. Here 2 root 3 I am getting, and in a question they have given root 3. So it means 2 I have to remove it. How to remove 2? Since 2 is in the multiplication part of the root 3, so it will go to the division part. So root 3 is equals to P minus 5Q by 2Q. Now again we have to stop here, and this is our last line. After that what we have to do? Just we have to do the comparison between LHS and RHS. What kind of comparison? Since LHS is equals to root 3, which is irrational, it is given, but RHS is P minus 5Q by 2Q, which is a rational number. Now one question can come into your mind that how come this is an irrational number or a rational number? Since root 3 is irrational, but why I am telling this is rational? Because we have taken P and Q as rational, so the sum or the difference of a rational number will always remains the rational only, and the division of a rational is also a rational. Hence we can easily say that LHS is not equals to RHS. Therefore assumption was again wrong. Assumption was wrong. And if the assumption is wrong, which implies that the given question 5 plus 2 root 3 is irrational, because we have assumed as a rational, but it is coming it as a irrational number. Similar kind of question, 4 question we have solved. So question 4 we are going, how we have solved 4 questions, since this is question number 3 only, because in question 2 I have given you one question as a homework. So we are moving towards the question number 4 of today's topic. Now, is it this question is little bit different than what we have learned just now? Till now we were doing the proving question, but this question is something else, where it is written 3 bells rings at some interval 6, 12 and 18. How come this is a real number question? So this is a part of real number question where you are going to apply the application part of real number, HCF or LCM. It all depends on your logical thinking. What they have given, let's first read, then we will go further. Now, let's read this first part. So 3 bells rings at 6, 12 and 18 minutes. Let us suppose just 1 minute guys. So suppose bell 1 is ringing at every 6 minutes. Bell 2 is ringing at every 12 minutes. Bell 3 is ringing at every 18 minutes. Now what is the time they have mentioned? They have mentioned that if all 3 bells rings together, all 3 bells ring together at 6 am. 6 am. When will they ring together again? So when will they ring again together? That we have to find. So let's see. First try to think that which case, which application part of real number is this? Is this a HCF or an LCM question? First of all, at 6 o'clock in the morning, if it is ringed together, all 3, so it means the next means the higher, either 7 o'clock, either 8 o'clock or 6:10, 6:20, 6:30, more than 6. So if it is going with a multiple of 6, it means 6, then 12, then 18, then 24, then 30 and dot dot dot. Same way this is going with a multiple of 12, so 12, 24, 36 dot dot dot, and this is going with a multiple of 18, 18, then 36, then 54, then 72 and dot dot dot. Now what is the time when all 3 are ringing together? Can you see that 6 is present here but not here, 12 is present in this 2 but not here, 18 is present in this 3 but not here. So what is the thing that we are going to find? Some bigger number from the given point. So when you are going for the multiple of some number, where we are going? We are going for the multiple, not for the factor. If I am going for the multiple, multiple means LCM. Multiple means LCM, and we know how to find the LCM of 3 number. It means we have to find LCM of 6, 12, 18. Now if you want to use LCM method, which you have learned in lower grade, that also you can use, or a prime factorization method of LCM also you can use. So here we are going to use the lower grade method, that will be easy for us. 6, 12, 18. So by which number you want to start? Start with 6 only. 6, 1, 6, 2, 6, 3. So what we got? 6, 2, 12 and 12, 3, 36. So we got 6 cross 2 cross 3. It means 3 to 6, 6, 36 minutes. So all three bells are going to ring together after 36 minutes. After 36 minutes means what? So when they are ringing, so ring again at, before they are ringing at 6 am, now 36 minutes more you add it, so 6:36 am. 6:36 am. 36 minutes is common in all. So here also we are getting 36, you can see, and in remaining two also you are getting 36. So 36 is that first number which is common in all three. So if you are going for the higher, it means you are going for the LCM. If you are going for the factor, it means you are going for the HCF part of the given question. This way we are going to solve such kind of question. This is application based question from CBSE 2023 real numbers. Is it fine? Let's go for question number 5th. Now read this question. What is the HCF of the smallest composite number and the smallest prime number? What is prime number and what is composite number? First, this should be clear in our mind. Prime number means such number which have only exact two different factor, and one factor is 1 and other factor is that number only. So the first prime number is 2, because 2 have only two factor, and which two factors are different, 1 and 2. 2 is divisible by 1, 2 is divisible by 2. Second prime factor is 3, which is divisible by 1 and 3. Third prime factor is 5, which is divisible by 1 and 5. So in between this we got so many numbers. So first focus on this. We got 1. Okay. Let's see. First number we got as 1. Second we got 2, 3, 4, 5. So what about 1? How many factor 1 will have? 1 will have only one factor. 2 will have two factor, 1 and 2. 3 will have two factor, 1 and 3. 4 will have three factor, 1, 2 and 4. And 5 will have again two factor, 1 and 5. So the minimum number of factor we are getting is 1, that is this. And second, 2 factor or 3 factors. So if a number have exactly two different factor, that type of number is known as prime. And if a number have more than two factors, that is known as composite. Composite. And this is prime. And this is a unique number. 1 is a unique number, 2 is a prime number, 3 is a prime number, 4 is a composite, and 5 is also a prime number. 2 has a special character that 2 is one and only even prime, and 3 is the first odd prime. The first odd prime. Now read your question again. Now you can read your question. What is the HCF of smallest composite number and smallest prime number? So we know the first case. First case is HCF of smallest composite number, comma, smallest prime number. Smallest prime number. So first of all we should know which one is the smallest composite number. Just now we got 1 is not a prime, 1 is not a composite, 1 is a unique, 2 is a prime, 3 is a prime, 4 is a composite. So the smallest composite number is 4. And the smallest prime, 2 was the smallest prime. What is the HCF of 4 and 2? HCF means the least, highest common factor. Name is highest, but we have to go for the lowest. So HCF of 4 and 2 is 2. HCF of 4 and 2 is 2. So we got our answer as 2. So first part is done. Read the second question which they have asked in CBSE 2019. Previous was 2018. This is also having a very good application of real number, where they have asked that two integers is there, second part, where the value of a they have given as x cube y square, and the value of b they have given as x into y cube. One more important property they have given, that x and y are prime. They have to be prime, because the first slide which I have shown, I have told you fundamental theorem of this arithmetic or fundamental theorem of calculus. It states that any composite number can be written as a product of prime. So a and b was composite, but x and y are the prime, and we have written in the power of product of prime. Now what we have to find? Find the LCM. They have given to find the LCM, but I am changing this question for you. You find HCF also. HCF also. So let's see how we are going to proceed. If I am going for the LCM part, left hand side, right hand side, if I am going for the HCF part. Okay. Now first let's go for the HCF part, then we will do the LCM. HCF means highest common factor. First of all, we have to check which prime is common in both. X is present in both, so I will write x, into y is present in both, I will write y. Now HCF, the first letter H states that highest, but we will go for the lowest power of that common variable. X lowest power is 1, okay, and y lowest power is 2. So what is the HCF value we got? We got xy square. This is your HCF. Done. But in this CBSE have asked about the LCM. Now LCM states that least common multiple. What does that mean? It means either that variable is common in both or not. First take all the factors of that number, x into y. Name is list, but always go for the highest power of that particular variable. Highest power of x is 3, highest power of y is 3. So the LCM is x cube y cube. X cube y cube. So here I am writing some note for you people. You can note it. This will help you in the examination. While finding LCM, always take highest power of each prime. But when you are going for the HCF, take lowest power of only common prime. Only common prime. This is very important part for you. Here I have written only common prime, and here I have written each prime. Either it is common or not common. Both you have to take. So this is a way to solve this such kind of question. This is one marker question, mostly they used to ask in one marker. Okay. Now let's see the question number 6 for the day. Question number 6. Now question number 6. This time a different kind of application they have given. What is this? First let's have a look. Write the number of zeros in the end of a number whose prime factorization is this. This is totally different. What is the meaning of number of zeros? So first we should know the meaning of number of zeros. What is the meaning? Meaning of number of zeros. Meaning of number of zeros, it means how many pairs of 2 and 5 you are getting in your overall prime factorization. Pairs of 2 and 5 in prime factorization. That many zeros will be there. Like suppose I am giving you a number as 10. 10 I can write 2 cross 5. I am writing 100. 100 I can write 2 cross 5 into 2 cross 5. Same way, if I want to write 50, I will write 5 into 10. 10 I can write 2 cross 5. So what we can observe here? Observe something. Try to observe, student. How many pairs of 2 and 5 I am getting in the first case? 1 pair. How many pair of 2 and 5 I am getting in the second case? 2 pair. Here 1 pair. It means that 5 is alone. There is no such 2 to make a pair. This number of pair of 2 and 5 will decide the number of trailing zeros. How many zero you are going to get. That's why here we got only 1 0 because 1 pair. 2 pair 2 0, 1 pair 1 0. Same technique we are going to use in the given question. Now let's move to the question. So the question, first part, A part I am writing. This is A part, this is B part. Write the number of zeros in the end. Prime factorization they have given. Suppose the number I am writing n equals to 2 power 2, I am writing 2 power 2 into 5 power 3 into 3 power 2 into 17 power 1. It means I can write 2 cross 2 cross 5 cross 5 cross 5 cross 3 cross 3 cross 17. Now, how many pairs of 2 and 5 I can write together? This 2 and this 5 I can write in a pair. Second, this 2 and second 5 can I write in a pair? Now, the remaining, if you will focus, this 5, 3, 3, 17, there is no such pair of 2 which will help them to make zeros. So, how many pair I am getting? Pair 1, pair 2, which implies that number n will end with how many zeros? Only 2 zeros. Why? Because we got 2 pairs of 2 cross 5. So, as many pairs, that many zeros. As many pairs, that many zeros. Next one is the HCF of two numbers A and B is 5 and their LCM is 200. This is one more important question of this part, where we have to use again some other type of application, but that second part. So, I am writing this as B part, part B. First of all, what I have told you at the starting, HCF of two number into LCM of two number is nothing but a product of that number only. What they have given, we will go accordingly. They have given HCF of two number A and B is 5. So, in place of HCF, I can write 5. And their LCM is 200. So, in place of LCM, I can write 200. They are asking what is the product of AB, which is equals to AB. So, just multiply 200 into 5 is nothing but 1000. So, we got the product done. So, this all one marker question is very easy, just if you are remembering the formula. Which formula you have to use, that it should come in your mind at the correct time during the examinations. So, don't be panic while attempting the question paper. Whenever you are attempting, read it in such a way so that at the starting 15 minutes, that reading time only, you should categorize your question, that which question I am going to solve and how much time it will take. All one marker question where MCQs are there, quickly finish it within 12 to 15 minutes if you are very good with the concepts of everything. Concepts of real number, concepts of trigonometry, which we did in the previous session if you remember, application of trigonometry and trigonometry part. And today is the session about this real number system. So, let us see the next part of this question number 7. Till question number 6 we have done. Now, question number 7. Now, this comes under 3 marker. This is a short answer question, not very long answer question. It is a short answer question. A fruit vendor has 990 apples and 945 oranges. So, suppose if I am starting this question, solving part. So, how to start? The first I will write the given part like number of apples. Number of apples is equals to 990. Number of oranges. Number of oranges is equals to 945. So, what will be the total number of fruit I have? Total number of fruit is the sum of 990 plus 945. 0 plus 5 is 5, 9 plus 4 is 13, 1 carry, 9 and 18 and 19. You are getting 1935 as a total. Now, what they are telling, he packed them into the basket. That a fruit vendor wants to pack 990 and 945 apple and oranges into the basket. Each basket contain only one of the two fruit. It means we can't mix it. Each basket will contain only one fruit and that also equal in number. Find the number of fruits to be put in each basket in order to have a minimum number of baskets. So, first of all, the quantity of apples and oranges are fixed. We are not going to increase. So something which you are not going to increase, it means we are going to factorize that thing. What we are going to do? We are going to factorize, and the word factor will define that we are going to do LCM or HCF. We are going to do the HCF because we are factorizing, we are not multiplying the numbers. So what is the meaning of factorization now? It means first find how many fruits I am going to keep in one basket. So fruit to keep in one basket is nothing but HCF of two numbers. Which two number? 990 and 945. Now let's solve for the HCF part. How we are going to solve for the HCF part? 990 and 945. So we know 990, you know 945. Now normally we know how to find the LCM. So just do the LCM step only and stop at such a place where you are not getting a common number by which you can divide both the numbers. Suppose I am starting with 5. So 5, 1, 5, 4 is remainder. 4, 9, 49. So 5, 9, 45. Then 4, 0, 5, 8, 40. This side, if I will start 5, 1, 5, 4, 4, 44, 5, 8, 40, 5, 9, 45. Now, by which number I should go? This time I am starting with 8 plus 1, 9, 8 plus 1, 9. It means we can go with 3. So 3, 6, 18, 3, 6, 18, 3, 6, 18, 3, 3, 9. Again we can go with 3 only. 3, 2, 3, 2, 3, 2, 3, 1. Now you can see that 22 and 21 is the such number which is not divisible by one number, a common number. So it means 22 and 21 are the co-prime number. Their HCF is already 1. It means this is our HCF. So the HCF of this is nothing but 3 power 2 into 5 power 1, which is 9 into 5. HCF is 45. It means in each basket I am going to just keep 45 fruits, either 45 apples or 45 oranges. Now, but the second part of the question is asking that number of fruits to be put in each basket in order to have minimum number of basket. How many baskets? So first case I am generating here number of apple basket. Apple basket will be was total apple divided by how many apple I am going to keep in one basket? 45. What is total apple? Total apple is 990 divided by 45. Second case was number of oranges basket. How many oranges basket I am going to put? So total orange divided by 45. Now how many total oranges are there? Total oranges is 945 divided by 45. Now do the division. Let's see what we are going to get. If you will divide, so 9 into 5 is 45, 9 into 1, 9, 9 into 1 and 0. 110 by 5. It means what I am going to get? 5 into 2, 10 and 5 into 2, 10. So there are 22 basket for apple. How many apple basket? 22. Same we will do for that. Now 45 and 945. So if it will, you will go this way 5, 5, 9, 45 and 5, 1, 5, 4, 4, 44, 5, 8, 40, 5, 9. So you got 189 by 9, which is equals to 9, 2 and 9, 1. It means how many basket for oranges? 21 basket for the oranges. So 21 basket for the oranges, 21, and for the apple, how many? 22. So total number of basket is 213, 224, 43 basket total, but 22 utilizing the apple and 21 is utilizing the oranges. This is the way to solve this. This was CBSE 2016 question. What we did first? Again, number of apple, number of oranges, total. since we have to keep the same fixed amount into the some small amount, it means I am factorizing. Factorizing means HCF, we got HCF as 45. Now the unit cost we got, like in a lower grade we used to do that 1 apple cost this much, so how much 10 apple will cost. So if you know the unit price, you can easily solve the question. So we know the unit price, now number of basket we have to find. So total apple I am dividing into the unit baskets. So 45 apple in 990 apple into the, in one basket 45 apples, so 990 divided by 45, you are getting 22. This side 945 divided by 45, you are getting 21 basket. So done with question number 7. Hope you all understood this part. Now we are moving towards our next question, that is question number 8. Question number 8. Question number 8, if you will read, they have written, prove that 4 power n can never end with digit 0, where n is a natural number. How a number can never end with digit 0? Just before this question, question number 7 we solved, and before that question number 6 we solved. In question number 6 we were doing the trailing zeros, the number of zeros. It means the pair of 2 and 5 will end up in zeros. It means they are telling it will never end with 0. What does that mean? They don't have a pair of 2 and 5. If we are not getting any pair of 2 and 5, it means our number will never end with 0. So let's break a number. So assume n equals to 4 to the power n, where n belongs to a natural number. Okay. Now how to break this number? I can write 4 as 2 cross 2 to the power n, which further can be broken it into 2 power n into 2 power n, correct? Which further you can write 2 to the power 2n, 2 to the power 2n. Did we get any pair of 5 which is not equals to 2 to the power some n into 5 to the power some n2, n1 or n2, where n1 and n2 is just the power, means a number, a natural number, where I can also write n1 belongs to natural, n2 belongs to natural. So what we got? If we are not able to write 4 power n is not equals to 2 to the power n1 into 5 to the power n2. Hence 4 power n doesn't have pair of 2 and 5. It will never end with 0. It will never end with 0. And done. Now if you want to check, verify that whatever you are doing that is correct or not, 4 power n means what? Which is the first natural number. Natural number, if we are taking small n, so natural number 1, 2, 3, 4, 5. So 4 power 1, 4 power 2, 4 power 3, 4 power 4, 4 power 5 you can check. 4 power 1 is 4, 4 power 2 is 16, 4 power 3 is 64, 4 power 4, 4, 4, 16 and 4, 6, 24, 256. What is 4 power 5? Multiply by 4, 4, 6, 24, 2 carry 4, 5, 20, 22, 2 carry 4, 2, 8, 9, 10, 1024. If you are observing, the first 4 is telling you the range you are getting 4, 6, 4, 6, 4, 6. Every time your last digit will end with 4, 6, 4, 6. It means nowhere zeros. Nowhere zeros. This is the last digit concept also. Putting the value and checking, hit and trial method. So this is one of the method. This they have asked in CBSE 23. Now let's go to the next part, which is question number 9. So since we completed question number 8, now we are moving towards the question number 9. So let's read first. Two numbers are in the ratio 2:3. So two number is given to us. Let us suppose first number is n1 and the second number is n2. Since they have given in a ratio, so we can't directly write n1 is equals to 2 and n2 equals to 3. So I am writing n1 is equals to 2x and n2 is equals to 3x. and they have given that their LCM is 180, find their HCF. So given part is LCM of N1 comma N2 equals to 180. LCM is given to you. HCF of N1 comma N2 they are asking. So this is the part. Now let's begin. How to find HCF? What is the relation we know? Relation is LCM into HCF of two numbers I am talking about is equals to product. So LCM of two number is what? Let the two number first of all see. This is 180. LCM they have given you as a 180 and product also they have not given us. So first of all what we should do, instead of directly substituting the value, first find the LCM. LCM of 2x and 3x. 2x comma 3x and HCF of 2x comma 3x. Since 2 and 3 is already a prime number, so x is the number which is common in both, because two primes can't be common, they are different. So LCM what we will get in this case, we will get 2 into 3 into x we are getting here, correct? In this part what we are getting? Only x, because x is the only thing which is common. So HCF we got x, LCM we got 2 into 3 into x. Now since LCM is equals to 180 and we got LCM value as 6x. So I can write 6x is equals to 180. So x is equals to 30 degree. Sorry, degree. I am telling this is not a degree, because this is not an angle property that we are writing degree. This is just a number 180, 180. So this is 30. This is 30. Now, so HCF becomes 30. Now I can substitute the value. I know the number. Hence, or I can write here, since N1 is equals to 2x. So it means 2 into, what we have to find? 2 into 30. So N1 we got 60, N2 is equals to 3x. So 3 into 30 we got 90. Now we got the number also. Now we got the number also and LCM, HCF also. Now you can see LCM was 180 degree and HCF what we got? HCF was x and product that we have to solve it. So instead of directly writing this part, you write it as LCM was 180, HCF was 30. So 100% what is the product I am going to get? 180 into 30. 180 into 30 is 18354 and 00. 5400. Since HCF I have taken as this, so this should be my answer. What HCF I am getting? 30 degree. So overall, therefore, HCF of 2x comma 3x, which is nothing but x, which implies that HCF of 180 comma 30 is nothing but 30. So this should be our final answer. So we got a number also. Number is 60 and 90. Number is 60. So here at last you can write the overall result. N1 60, N2 90, LCM 180, HCF 30, and what is the product? Product is equals to 5400. This is overall result. We got everything. N1, N2, LCM, HCF, then overall product. So this is the answer, overall answer. Same way we can go for the next question, question number 10. Now question number 10 is find the largest number which divides 70 and 125, leaving the remainder 5 and 8. This is CBSE 2015. This is CBSE 2015. And below one is also CBSE 2016 and 2015. So first question we are working. find the largest number which divides 70 and 125. So if I will subtract a remainder from the number, so on subtracting remainder, if I am writing this, on subtracting remainder from a number, it will result in a perfect divisibility. Perfect divisibility. Now what does that means, a perfect divisibility? It means now my first number was n1. What I am doing? 70. I am subtracting the first remainder minus 5. I got as 65. Second number is n2, which is 125, and I am subtracting 8. If you will, 125 subtraction 8 is there, so 117. Now the two number which we got as 165 and 117. They are telling find the largest number which divide. So first of all, I want to find the largest number which divide them. So first of all, again I am doing the division. Division means factor of things, not the multiple. So it means I have to go for the HCF of the given figure. So done. Therefore, HCF of 65 and 117. What is the HCF we are going to get? You can solve here only. HCF 65 I can write as 5 power 1 into 13 power 1, and 117 I can write as 13 into 3 power 2. 3 power 2, because 13 into 9 is 117. So what is the HCF value I am getting? HCF means highest common factor. So first of all, it should be a common one. So 5 is not present in second, 3 is not present in first, 13 is present in both, and HCF name is H, which is highest, but I have to take the lowest value, 13 power 1. So my answer should be 13. So what is the HCF I am getting? 13. They have asked largest number which divides. So 13 is that largest number which will divides number 70 and 125 if I will subtract the remainder 5 and 8. So first part is done. What about the second part? Second part is 7. They are asking is 7 cross 5 cross 3 cross 2 plus 3 is composite. We know the composite is such number which on factorization it should have more than 2 factors, because if it have 2 factors it will be a what kind of number? A prime number. So let's see. I am writing 7 cross 5 cross 3 cross 2 plus 3. So we can see that 3 is common in both. So I am taking 3 outside. So remaining is 7 cross 5 cross 2 plus 1. Now 3 into 7 5 35, 35 into 2, 7 into 5 35, 270 plus 1 71. We are getting 71, and since 71 is a prime number, so we can't further factorize. So what factor we got? Suppose this number is n. So we got n is equals to 3 cross 71. And 3 cross 71, how many factor it have? The first factor is 1. Second factor is 3. Third factor is 71. Fourth factor is 3 cross 71, a number itself. So we are getting a total number of 4 factor. Hence it is composite. Hence it is composite. So this is the way to solve the question. This is also 1 or 2 marker question, because we have to justify our answer. The word justification is very important for you. If they have not given the justification, you can directly write. But they have given the justification, so you have to show some steps that how you are breaking it into, then on combination how many factors you are getting. So question number 10, we are moving towards the question number 11. Now see question number 11. Find the largest number which divides 650 and 170. Again the same word, largest number. Largest number means what? largest number which divides. Divide means HCF. Divide means HCF. So the largest number which divides 650, which divides 650 and 1170 is equals to what? Is equals to nothing but it is an HCF of 650 and 1170. So for HCF, prime factorization method we are going to use. Prime factorization. So 650, if I will break 650, what I will get? 51530. Means better write like this. 515, 5315 and 0 direct. Then again 13, 1, 0. Then again 5, 2 and 2, 1. Second is 1170. 1170 if you will go, what you will get? If you are going with table of 2, 2, 5, 10, 2, 8, 16 and 2, 5, 10. Then again go with 5 table, 5, 1, 5, 5, 1, 5, then 5, 7, 35. Then we know that this is divisible by 13, 13 into 9. So we can break it into 3, break it into 1. So what factor we are getting here? I can easily say that 650 I can write as 2 into 2 power 1 into 5 power 2 into 13 power 1, and 1170 I can write as 1 2 power 1 again, this time 3 power 5 power. So 3 power 2, 5 power 1 and 13 power 1. So while finding the HCF part, first we have to focus upon which one is common. So HCF of 65 and 1170, 650 and 1170 is common number. 2 is common, next 5 is common in both, next 13 is common. After common, which is having the lowest power, 2 lowest power is 1, 5 lowest power is also 1 and 13 lowest power is also 1. So what we got? 10 into 30, 130 is the HCF. So what is the largest number you got? 130 is your largest number which will divide 650 and 1170. Next part of this they have given, read it, find the HCF and LCM of this using prime factor. This is direct question they have asked, so no need of using any logic also, direct you can do. HCF of, suppose A is 65, sorry A is 26, B is 65 and C is equals to 117. So always first break your number into the prime factor. 2 into 13 is this, so 2 power 1 into 13 power 1. 65 is 13 into 5, so 5 power 1 into 13 power 1. 117 is 3 power 2 into 13 power 1. The first thing they have asked about the HCF, then the LCM. So the HCF of 3 numbers, 26, 65, 117. HCF should be a common number first of all. So 2 is present in all? No. 5 is present in all? No. 3 is present in all? No. Only 13 is present. So HCF is 13. Now we can go for the LCM part. LCM of these numbers. Here please don't apply the relationship HCF into LCM is product of number, because that is applicable for 2 numbers, not for 3 numbers. So LCM of 26, 65 and 117 will be what? Again here either it is common or not, all the prime should come first. 2 cross 3 cross 5 cross 13, and after this highest power of each prime should come. Highest power of 2 1, 3 2, 5 1 and the 13 highest power is 1 only. Now if I will multiply, what I am going to get? 2 into 5 10, 10 into 9 into 13 and 10 will remain 10, 13 into 9 is 117. So we got 1170 as an our LCM. That's all. So what we got with the prime factorization method, we got the LCM as 1170 and the HCF as 13. Now let's move on to the question number 12. Question number 12. Just take a pause of 1 minute and please read the question once. Question is the greatest number which when divide 1251, 9377 and 15628 and leaves the remainder 1, 2 and 3. They are asking about which will divide. With the term divide only you can segregate this question in terms of HCF or LCM. So the application part division means HCF. So this question is directly based on HCF. They have asked this question in CBSE 2021 term examinations. Now, so number I have taken suppose N1, N2 and N3. So let's write first properly. Let number be N1, N2 and N3. So what is N1? N1 they have given 1251, N2 they have given 9377 and N3 they have given 15628. But something they are telling which leaves a remainder of 1, 2 and 3. So whatever remainder is there, first subtract that remainder. Remainder 1, remainder 2, remainder 3. On subtraction whatever value you are getting, that number we have to find how it is completely divisible and by which number it is completely divisible. So 1250 is the first number, second 9375 is the second number and 15625 is the third number. So what we have to do next? Find the HCF. So therefore HCF of 1250, 9375 and 15625. Find the HCF. How we are going to find the HCF? With a common method we are going to find old method, lower grade method. 1250, next is 9375. Rub this part, 9375 and the last one is 15625. So start with a division by 5 only, so that quickly we will reach to the final answer. 5 to 10, 2 5, 5 5 25, then 0. 5 1 5, 4 3, 5 8 40, 3 7, 5 7 35, 2 5, 5 5 25. Then this is 5 3 15, 5 1, 5 2, 5 5. Now 250, 1875, 3125. Again go with 5. What we will get here? 550, 5 3, then 3 7 37, so 5 5, 5 2. Just a minute. This part rub it. 5 3 15, then 3 7, so 5 7 35, then 5 5 25. This is 5 6 30, 5 2 10 and 5 5 25. Again go with 5 only. 5 10 50, 5 7 35 and 5 5 25. This is 5 1, 5 2, 5 5. Again go with 5, 5 2, 5 1, 5 5 and 5 2, 5 5. Now 2, 15 and 25. No such number exists in which table 2, 15 and 25 all three are coming together. It means here only we have to stop and whatever is our divisor, this number will become our HCF. So HCF is 5 cross 5 cross 5 cross 5, which is 25 cross 25 and which is nothing but 625. So this is the HCF, which is option number D. So this was the 1 marker question which they have asked. Now we are moving towards the session end. So last question is remaining for you. Then we will brush up, we will wind up this sessions. So let's move to the last question of today's session. This last question. And this question is very important in board perspective. They have asked in CBSE sample paper question 23 and 24. Let's have a look on this question. National Art Convention got a registration from students from all parts of the country, of which 60 are interested in music. So from here only just stop yourself and first segregate the things what is given in the question. So given part is in music, then in dance, and the last part is interested in handicraft. So I am writing HF. In music, how many students are interested? 60, then 84, then 108. This is the total number of students if you will count. That will be how much? 8, 4, 12, 1 carry, 10, 8, 18, 6, 24, 252 total students are there. They are telling for optimal culture exchange, organizer wish to keep them in a minimum number of groups. What is the meaning of minimum number of group? It means we are not increasing something, we are decreasing, and decreasing means again HCF. So these are all the application part of real number, LCM and HCF. So minimum number of group, so how many groups I am going to find? So let's solve that part. Such that each group consists of a student interested in the same art form and the number of students in each group is also same. Find the number of students in each group. So number of student in each group. Number of students in each group will be nothing but HCF of 60, 84 and 108. What will be the HCF? That we are doing this side. 60 you can break it into 30 into 2 and 30 you can break it into 5 into 6. So we are getting 5 cross 6 30 into 2. So now that 6 also you can break it into 2 into 3. So I can write 3 to the power 1 and 2 to the power 2. Now 4, 3, 12, 5, 60. This 84 I can write it as 12 into 7 and 12 is nothing but 2 power 2 into 3 power 1 into 7. 7, 3, 21, 2, 21, 4 is 84. Last is 108. Now if I am breaking 108, 12 into 9 is 108. So 12 is 4 into 3. So I can write 2 power 2 into 3 power 3. 3 power 3 is 27, 27 into 4 is 108. Now to find the HCF, HCF means always common one. 5 is not present, 2 is present here, here and here. So 2 is the first common number. Second, 7 is not present, 3 is present in all. Now after taking the common number, always take the least power of the common number. Least power of 2 is 2 only and least power of 3 is 1. So what we got? 4 cross 3. It means 12 number of student in each group. Number of student in each group. This is only the first part of the question we have done. Remaining part is there. So 12 number of student we got. Now they are asking find the number of group in each art form. So number of group in first one, music. So number of group in music will be what? Total number of student in a music divided by number of in one group how many student I am going to accompany. So 60 student by 12. So there will be 5 group. Second, other than music done. So next two is dance and handicraft. So for dance how many? Total 84 divided by 12 is equals to 7 and the last one is handicraft which is 108 divided by 12 is equals to 9. So total number of a group, how many group we are creating is the sum of all three. So total group is nothing but 5 plus 7 plus 9, that is 12 plus 9. 12 plus 9 is 21 groups. So total we are dividing 21 groups into 3 parts, 5 plus 7 plus 9 in which 12 students are there. Total number of students are 252. And we have done with. So how many rooms we are allotting for them? We are allotting 5 rooms for music, 7 rooms for dance and 9 rooms for the handicraft. That's all done. So here I am stopping my session. Thank you so much. But before stopping, I want to say that please practice whatever I have discussed in session 1, application of trigonometry, session 2 on the real number system. The combination of question which I have kept, you can check all our CBSE previous year question paper or the sample paper question. So please focus on the part, check the content, go and revise everything somewhere in between. I have kept that writing part, theoretical part also I have kept in between. And question, just check it how I am approaching towards the questions, not directly get into the answers, just solve and check what they are asking, how to apply the application part. And in a trigonometry also, just go on and revise all the identities and everything. That's all for the day. Thank you so much.